This is another video for 3.1 and 3.2 involving linear systems. Today we're going to still be solving linear systems using either substitution or elimination, but the first step is to actually set up the system of equations. So we're going to be given a problem, and the first thing we need to do is identify the two variables. You can use x and y every single time if you want. A lot of times with word problems, I actually like to use variables that help me remember what they're representing. So that's up to you as well. So this first one I'm going to use x and y, and then I'm going to kind of switch it up as we go. Okay, so the sum of two numbers is 7. So sum is addition. And anywhere I hear the word or see the word is, that's where I'm going to put an equal sign. So I'm adding two numbers and they equal 7. If one number is subtracted from the other, their difference is -1. And difference is just the answer to a subtraction problem. So I have two numbers. When I add them, they equal 7. And when I subtract them, they equal -1. Find the numbers. So this last sentence here is basically telling me what my variables need to be. So I'm going to have x be the first number, and y is the second number. Okay? All right, so we have, when we add them together, so x and y are my two numbers. When I add them together, it equals 7. And when I subtract them, it equals -1. Okay, so we are going to, Okay, so we're going to proceed with whatever method I want. So I could do substitution or elimination. I'm going to do elimination because my y's are already opposite. So if I add them, I'm going to be able to eliminate those. I didn't have to even multiply. So I get 2x equals 6, divide by 2, and I get x equals 3. So my first number is 3. Now I need to find the second number. So just like before, once I get one of the variable solutions, I have to plug it back into one of the original equations to get the other. I'm just going to use the top equation. So x is 3, so 3 plus y has to be 7. So y has to be 4. So the two numbers that fit this, that solve this system are 3 and 4. Okay? All right. A hotel has 200 rooms. Some have kitchens and some don't. Those with kitchens rent for $100 a night, and those without rent for $80 a night. One night, the hotel was completely full, and the total revenue was $17,000. How many of each room is in the hotel? Okay, so the question is what my variables need to be. How many of each room? So there are kitchen rooms and non-kitchen rooms. So I'm going to use K and N. K for kitchen rooms and N for non-kitchen rooms. Okay, so again, you can use any variables you want, you guys. I like to use ones that help me remember what they're representing. So I'm going to do this. So now a lot of times when we're dealing with money, a lot of times one of my equations will deal with just the number of things, and then the other will deal with the cost of things. So for example, the number of things is I have a certain number of kitchen rooms, a certain number of non-kitchen rooms, but total I have 200 rooms. So the kitchen rooms plus the non-kitchen rooms in total has to be 200 rooms. Okay, I don't know how many of each, but I know total there's 200. Then I have an equation involving the cost of everything. So we have cost per kitchen, cost per non-kitchen, and then the total. So that's going to go together in one equation. So the kitchen rooms are 100, the non-kitchen rooms are 80, and then the total revenue when all of the rooms were rented was $17,000. Okay, now I just get to pick a method that I want to solve the system for. I'm going to do substitution on this one because solving this is really easy to get one of the variables by itself. I'm going to go ahead and solve for k. So I'm going to subtract n. So k is equal to 200 minus n. So this I can substitute into the other equation for k. All right, so I have 100 instead of times k. I'm substituting in the equivalent expression. Okay, and then I got a little bit of work to do here. So let's see, what do I get? 2,000, 20,000 actually, minus 100n plus 80n equals 17,000. Okay, and then combine some like terms here. So I've got, let's see, my n's. So I got 20,000 minus 20n equals 17,000. Subtract 20,000 from both sides. Lots of zeros. Negative 20n equals negative 3,000. 30,000, sorry. Whoop. Oh no, I had that right. 3,000. There we go. And divide by 20, negative 20, to get n is equal to 150. Okay, so n, remember, was representing the number of non-kitchen rooms. So I'm going to take n, I'm going to plug it back into that top equation to get k. So I have k plus n, which is 150, equals 200. Subtract, so k has to equal 50. So there are 50 kitchen rooms. I'm going to specify too with these ones, you guys, since it's not really, it is an ordered pair, but it's answering the question to a word problem. So we want to put the units on whatever our solutions are. So writing a sentence or just specifying again what those variables are is a good idea. So there are 50 kitchen rooms and 150 non-kitchen rooms. So this is truly answering the question, how many of each room are in the hotel? So that statement really specifying what the 50 and 150 are is necessary for answering these problems. Okay? All right, we got two more here, you guys. All right, so we have a company that manufactures canoes. It has a fixed cost of $18,000. So what that means is the company just requires $18,000 to operate. That could be facility costs, it could be employees, materials, whatever. So it automatically is going to cost $18,000 right up front. And then each canoe that they produce costs $20 for them to make. And then they sell them for $80. So how many canoes must be sold to break even? Okay, so breaking even is like they've repaid the $18,000 and the $20 for every canoe they made, and they're not in debt anymore. And then obviously they'd be happy with anything above that. But we want to know, what is that point at which they break even? How many canoes do they have to make? So we need to answer this question, how many canoes? So I'm going to let x equal number of canoes. Okay, and then break even has to do with money. So that's kind of another like hidden variable a little bit, is the money it takes for something to happen. So we're going to have y equal the amount of money. Okay, so there are kind of two hidden variables in that question. How many canoes to break even? Okay, so here we go. So the amount of money it takes to run the establishment, right, is one equation. So the amount of money is $18,000 plus $20,000 per canoe. So that's where the times x comes from. Now the amount of money they can make just from selling the canoes is $80 per canoe. So this is my system. Okay, so I'm actually going to graph this just to show you guys kind of what's this going to look like. But we have one equation that has a y-intercept of $18,000 and then it has a slope of 20. So this is like the expenses equation. Expenses. Okay, and then we have just the money making. So they don't make any money for not making a canoe, right? The y-intercept is 0, and then the slope is 80. So it's going to be quite a bit steeper than this line. Okay, and so this is their revenue, what they're bringing in for each one. And the point where they intersect is that break-even point. Okay, everything above that is going to be profit. Everything below that, they're in the hole. Okay, so here's the break-even point. So we want to find what that is. Okay, so I could graph these two lines on a more specific graph to actually see what that is, but I'm going to solve using substitution. Y is already isolated here, so I'm going to substitute it in for y into the other equation. So if y is isolated in both, we can actually just set the two expressions equal to each other. So I have 80x equals 18,000 plus 20x. So I get, subtract the 20x, I got 60x equals 18,000. Divide by 60, and I get X is 300. Remember, X was the number of canoes. So it's going to take them 300 canoes to break even. So we actually just answered the question, but if we want to know what that amount of money is at which they break even, we could plug this back in. So I would do y equals 80 times 300, which is 24,000. So that means this point right here is 300, comma, 24,000. Okay, so at 300 canoes, the company will have spent $24,000 and sold $24,000, so that's where they're breaking even. So their bottom line is 0. Okay, so how many canoes? It takes 300 canoes to break even. So that's really answering the question. They didn't really ask about the amount of money, but we could have found it if we needed to. So 300 canoes for the company to break even. All right, last example. Okay, veterinarian needs 60 pounds of dog food that is 15% protein. He will combine a beef mix that is 18% protein with a bacon mix that is 9% protein. How many pounds of each does he need to make the 15% protein mix? Okay, so question, how many pounds of each? So the different ones he's combining are the beef mix and the bacon mix. So since they both start with B, I'm going to use X and Y again. Okay, so I have X is, let's do the beef mix, and Y is the bacon mix. Okay, so total he needs 60 pounds. Oh, so I should say pounds of that. Okay, it's because asking how many pounds. Okay, so we need 60 pounds total. So some pounds of beef, some of bacon. I don't know how much of each yet, but total has to add to 60. So X plus Y equals 60 is one equation. The other equation is going to deal with the percentages. So he wants to end up with a 15% mixture, okay? And we need, and each of these protein mixes have a different percentage. So we have the beef is 18% and the bacon is 9, okay? So we have 18%, I'm going to write it as a decimal, so 0.18x plus 0.09y. Now, here's what I don't want to just set it equal to 0.15 because I don't want this to equal 15%. I want it to be 15% of the total, right? So the total poundage, I want to be 15% protein. So the total poundage is 60 pounds. So I need, what is 15% of 60? Okay, so that's what I'm doing here. Anytime we say the word of, it's multiplication. All right, so simplifying this, 15% of 60, so 0.15 times 60 gives me 9, okay? All right, so this is going to equal 9. So I have, I'm just going to rewrite these both over here, guys. I'm going to use substitution again. I'm going to go ahead and subtract x. So I have y equals 60 minus x. And then here, I'm going to rewrite this one, 0.18x plus 0.09y equals 9. Okay, so I'm going to plug this now in for y. So I have 0.1x plus 0.09 now times 60 minus x equals 9. Okay, proceed with our usual solving steps. I'm going to distribute here. So now I got to find what is 9% of 60, 5.4. Okay, like terms, I get positive 0.09x plus 5.4 equals 9. Subtract 5.4, let's see, I get 3.6. Yep, 3.6. Okay, divide by 0.09 and I get x equals 40. Okay, so x again was our pounds of the beef mix, so now I know that, but I need to know how much of the bacon. So I'm plugging 40 back into the original, so I have 40 plus y equals 60. Subtract, y must then be 20. So, answer the question, we need 40 pounds of beef mix and 20 pounds of bacon mix. Okay, and there again, we're answering the question with kind of specifics to the context of the problem. All right, that is it for linear systems and word problems. Thanks for watching.